In order to draw a line, we need two things: a starting point and a direction. The slope of a line describes the direction of its movement. In this video, we will learn more about the starting point and how we can put everything together into an equation. In our last video, we learned how to calculate the slope of a line. Remember, the slope tells us how the y value changes in response to changes in the x value. For example, the slope 1/2 tells us that for every 2 units the x value moves forward, the y value will move up 1 unit. Because x values represent the change in x from x equals 0, multiplying the slope by an x value will tell us the change in the y value from the y-intercept. This works because the grid line at x equals 0 is the y-axis, and the y-intercept is the point where a line crosses the y-axis. Bringing this together, if we multiply the slope of a line by any x value, it will tell us the change in y from the y-intercept. So if we add the y-intercept to the slope times x, it gives us the new y value. Essentially, this boils down to the equation y equals mx plus b, where x can be any x value and y is the result of multiplying x by the slope of the line, represented by the variable m, and adding the value of the y-intercept, which is represented by the variable b. We call this form of a linear equation the slope-intercept form. Let's try writing the slope-intercept form of the line graphed here. If we look at the line, we see that for every 2 units of forward movement, the line goes down 3 units. So the slope is -3/2. The line crossed the y-axis at y equals 4, which is our y-intercept, so the equation of this line is y equals -3/2 x plus 4. We can also find the equation of a straight line given the slope and one of the points on the line. For instance, if we have a line with a slope of 3 that crosses through the point -1, 2, we have a value for every variable in our equation except the y-intercept. We could use our substitution property of equality to plug these values into our equation, giving us 2 equals 3 times -1 plus b. Because we only have one variable left, we can solve the equation to find the y-intercept. First, we will simplify the term 3 times -1, giving us 2 equals -3 plus b. I like to have my variables on the left side of the equation when I am solving, so I'm going to rewrite the equation as -3 plus b equals 2. We can do this because of the symmetric property of equality, which states that if a equals b, then b equals a. Going back to our problem, we need to move -3 to the right, so we're going to add 3 to both sides using the addition property of equality to get b equals 5. This means our equation for this line is y equals 3x plus 5. Notice that we wrote the final equation with x and y because -1, 2 is not the only point on the line, and we want our equation to represent all possible solutions. Writing the equation of a line allows us to describe the patterns observed on a graph without using as much space. It also allows us to more easily define points that lie in between 2 grid lines. In this video, we learned how to write the equation of a line in slope-intercept form.